Machine learning algorithms have been classified in various ways, but they are most commonly categorized on the basis of their purpose. The categories are supervised, unsupervised, and reinforcement. The supervised approach is similar to human learning under the supervision of a teacher. The teacher provides examples to the student, and the student then derives general rules from these specific examples. Similarly, supervised learning is task-driven. It occurs when an algorithm learns from example data and associated target responses in order to predict the correct response when posed with new examples. The target responses may consist of numeric values or string labels such as classes and tags. Machine learning takes data as input. This data is called training data. In supervised learning, the training data includes inputs and labels or targets. Here, the training data is called labeled data. This can be illustrated with the help of an example. Suppose you want a machine to learn the logic where it will calculate the sum of two inputs provided to it. You can provide a training data such as inputs 5 and 6, label or target 11. Drag the input data and then the label into the algorithm box for the machine to deduce the logic. Now, drag the new input data into the logic box to predict the new output. Therefore, supervised learning algorithms try to model relationships and dependencies between the target prediction output and the input features so that the machine can predict the output values for new data. Supervised learning is further divided into two broad categories based on the type of response required. These are classification problems and regression problems. In classification problems, the output is predicted as categorical response based on a set of inputs. The machine predicts one of the values in a set of values. In other words, the output variable is a category such as yes or no, or authorized or fraudulent. Some examples are: is the mail a spam? Based on inputs like sender mail ID, IP address, subject of mail, timing, etc. Will it rain today? Based on inputs like humidity, temperature, wind speed, etc. These are yes or no type questions called binary classification. Other examples are: is the mail a spam or an important one or a promotion? Is this a picture of cat or dog or tiger? These are examples of multi-class classification, as the response is chosen from more than two classes. In regression problems, the output is predicted as continuous response based on a set of inputs. The output variable is a real or continuous value such as salary or weight. Some examples are: what is the price of a house in a specific city? Based on inputs like location, number of rooms, area, age, etc. What is the value of the stock? Based on inputs like GDP, profit of the company, industry average, last trading price, etc. Besides these, two more techniques are considered under supervised learning, though they are separate approaches in themselves. These are time series forecasting, ensemble techniques. Unsupervised learning occurs when an algorithm learns from examples provided without any associated response. The algorithm determines the data patterns on its own. This type of algorithm tends to restructure the data into something else, such as new features that may represent a class or a new series of uncorrelated values. They are quite useful in providing humans with insights into the meaning of data and also new useful inputs to supervised machine learning algorithms. Therefore, in this type of learning, the training data does not include targets. Here, you do not tell the system where to go. The system has to understand itself from the data provided. Unsupervised learning is mainly used in pattern detection and descriptive modeling. There are no input categories or labels here based on which the algorithm can model relationships. These algorithms try to use techniques on the input data to mine for rules, detect patterns, and summarize and group the data points. These help in deriving meaningful insights and describe the data better to the users. Unsupervised learning can be further classified into clustering, association, and anomaly detection, of which clustering is the most common one. In clustering, similar things are grouped together. This is similar to multi-class classification, except that the labels are not provided here. The system interprets the label from the data itself and clusters the data accordingly. Some examples are: several news articles are clustered into different types of news. A set of tweets are clustered on the basis of the content of tweets. A set of images are clustered on the basis of types of images. Clustering, association, and anomaly detection problems are discussed in detail in subsequent topics. In reinforcement learning, the algorithm is presented with examples without labels, as in unsupervised learning. The algorithm determines the solution on its own. On the basis of this solution, a positive or negative feedback is provided. This helps the algorithm to learn the correct responses. An interesting example of reinforcement learning occurs when computers learn to play video games by themselves. It is just like learning by trial and error method in the living world. Errors help to learn because they have a penalty associated with them in terms of cost, loss of time, regret, pain, etc. Reinforcement learning is used in applications where the algorithm is required to take decisions which bear consequences. Reinforcement learning has not been discussed in this course as it demands a separate course of its own due to its advanced and complex nature.